Right. Hello, everyone, and welcome to Synthesizing Cyber Infrastructure Efforts of C4P and the EarthCube Community, a webinar series organized by C4P. C4P, Collaboration in Cyber Infrastructure for Paleo Geosciences, is an EarthCube research coordination network supported by the National Science Foundation. I'm Leslie Shee, and I'll be the moderator today. In today's talk, we have one presentation. So it will definitely be under an hour. If you have any questions, please send them through the WebEx chat window to Research Coordination Network, and I'll read them aloud after the presentation. You may send in a question at any time. All presentations and follow-up discussion will be publicly archived on the EarthCube website and at the C4P YouTube channel at youtube.com/Cyber4Paleo. Today, our speaker is Ilya Zaslavsky from San Diego Supercomputer Center, and he's giving an update on the CINERGI building block project. So we're actually in the same room today, and Ilya has the screen share and audio on, so begin when ready.
Okay. Hello, everybody, and thanks, Leslie, for the introduction. I'm happy to be here and have an opportunity to present the project to you. I'm speaking from SDSC, where we actually have a CINERGI user workshop. It's a lunchtime, so most of the folks left to get some food, except for Leslie and Steve Richard, who is also a member of the CINERGI project. So we will try to do it together, we really hope for your questions, and if you feel that you want to interrupt me at some point and ask questions, please do that. It would be much more interesting for me than just to do it without any feedback, immediate feedback. Okay, you've certainly heard of CINERGI project. It's one of building blocks that was funded a year and a half ago. It is the second time I give a C4P webinar. First time was more than a year ago, and last night I was quite stressed, thinking that I don't really want to show the same slides again that I showed last year, and fortunately it turns out that the slides that I have now have nothing to do, no, they kind of follow the same theme, but these are all new slides. The only slide that will be the same is a list of goals of the project. It is the same, but everything else has changed to reflect some quite substantial developments that happened in the project. So let me start the slideshow, and please feel free to interrupt me, as I said. CINERGI stands for Community Inventory of EarthCube Resources for Geoscience Interoperability. This is a list of people who are involved in the project. Co-PIs are Steve Richards, Kirsten, Tanu Malik from University of Chicago, Louis from OGC, and also Amarnath Gupta and Jeffrey Greasy from UCSD, who have been heavily involved in neuroscience integration projects, and some of the technology that we have used comes from these projects. Others.
Yeah, if I may interrupt you, could we try to get this full screen, maybe with the display settings at the top?
Display settings, duplicate.
Yes. Okay. Great.
Okay. Thank you. All right. Next one. Some of the dilemmas that we have to deal with. If you look at summaries of EarthCube end user workshops, discovery of data and other resources is one of the most important themes, most often cited. At the same time, you will hardly find papers that attribute some scientific contributions to discovery. So there is some disconnect here. It's definitely part of infrastructure that ideally should be hidden, kind of non-intrusive, but at the same time is very important for the whole science enterprise and data discovery, analysis, and so on. Perhaps this disconnect results from our lack of understanding of what scientists mean when they talk about data discovery. We have actually talked about that a little bit at the workshop, because discovery may include just finding data, but also trying to understand what this data mean and see if this data are fit for specific purpose. And finally, if you can integrate this data or other resources directly with other data that we have. So these three stages: discovery, understanding, and assessment of fitness for use, and integration and modeling. We do not cover all of them. We mostly cover discovery. Another interesting issue is what we want to discover. Typical catalogs deal with data sets. There are also databases used by that have been developed by multiple groups. In fact, when C4P has put some effort into cataloging available resources, lots of these resources are databases. At the same time, when we look at use cases, many of them refer to observations, specific observations that may be hidden within data sets and databases, but need to be discovered and correlated. There may be discovery of features of interest. There may be discovery of people, for example, who has been working on a particular research or who has used this data set or that model. Another interesting dilemma is, do we want to do it in a centralized fashion, or do we want to have a sort of discovery triaging mechanism? We just want to figure out which database or which domain data system would be able to respond to a request, and then pass that request onto that system. There are pluses and minuses of both. In the centralized approach, you kind of have more control. You can process and enhance your metadata and execute more complex queries. In a distributed system, such evaluating cost model for the queries may be more complex, and also you need to have fairly well-defined service level agreements, because if something happens at your service provider, they change an interface or they modify information model fields, then your communication may break. So in fact, in some domains, there have been experience of using both this brokering, distributed approach, and centralized discovery, and results are mixed. Like in neuroscience, there was a transition from so-called BURN project that tried to implement a broker or mediator, rather, to search across multiple resources, but eventually the system transitions to a more centralized data discovery, and the project is now called NIF, Neuroscience Informatics Framework. Another question is, I think I'm going too slowly, right? I'll go fast. What is the result of discovery? When you can say, I'm done with discovery, now I can switch to another phase of discovery, or find some other relevant data, or say that I found what I want and now can start processing or modeling or something like that. That is not very well defined because typically in geosciences we have kind of cascading queries with lots of iterations. Another philosophical question is why we need inventories in EarthCube at all. A very often common question is, what is EarthCube? And inventories may be useful because you can say, okay, this is a set of resources that have been assembled and certified by EarthCube as something that is managed, compliant with EarthCube standards, and is available for the community. Seeing what's available, avoiding duplication. If you can find that somebody else has already implemented that functionality or has this data would be useful before you embark on certain research. Supporting these three levels of data discovery, data understanding, and integration would be impossible without having a registry of what's available. Organizing communities around shared use of information resources is actually a fairly important component of EarthCube inventories, I think. At least several RCMs have, including C4P and CEN, started developing inventories of common data sets that I use within the community, and that has been one of the foundations on which different people come together to share this data. Monitoring resources, certifying EarthCube resources and getting credit for them, and also trying to see if these resources can be composed into architectures. So you can think of EarthCube architectures not as a single reference design, but something you compose from available components for your specific task. And EarthCube would just impose some additional requirements on such compositions. For example, these compositions or architectures should have some monitoring and feedback components to them, should connect to governance mechanisms, should be reproducible, and so on. Oh, that's the slide that came from the earlier presentation about a year ago about the goals of the project. To create a large inventory of high-quality information resources across disciplines with traceable provenance, something that can be used across different research scenarios and domains. Engaging community and enabling search and integration across domains and facilitating navigation. Some of these things are actually quite difficult to implement. A large inventory of quite high-quality information resources, we don't really know the quality of resources in most of the inventories. We can try to compile a large pile of metadata records, but they would be hardly compatible. And this is actually what we are running into. But before telling you about the issues, this is the overall scheme of metadata publishing in CINERGI. We compile the overall inventory by harvesting catalogs from multiple domains and passing them through a pipeline that improves metadata. We also harvest this information from community contributions that comes through community resource viewers. I will show more of these viewers later on, but these are online applications where you can add resource, edit resource, share what you have edited with other folks, and also analyze and browse resources in different ways. One of such inventories is inventory of all resources that have been submitted through end-user community workshops, and you can find resources mentioned. If you participate in those and submitted resources, chances are that they will be here. Now, why is this a problem? This is a snapshot from Inspire validator results. You can follow this URL, actually let me do that, and see by yourself. Inspire is a European initiative that specifies interfaces and standards that published data sets should follow. So at some point they created a validator to assess compliance with the standards, and you can see that out of 281,851, there were 281,866 records apparently, and of which 15 passed validation. I asked some Europeans as to why that happened, because the results don't look too impressive. And they said, well, you know, there are standards, but certainly people enter metadata as they feel would be sufficient for describing their data sets without, you know, not exactly following the INSPIRE standard. Also, that is supposed to be a law in Europe. If you have explanations, or if you know something why this happens, please let me know, because the results are really funny. Okay. How do I get back? All right. So you see that there is a problem. The problem is that we have lots of data sets with metadata descriptions that are incomplete or wrong or domain specific, or they have other idiosyncrasies that would prevent cross-domain use of such resources. What we're trying to do in CINERGI is to harvest metadata records from multiple resources, put them into staging database. It's a MongoDB into which we load XML or other types of records and present this as JSON objects. And then apply a bunch of document processing components that essentially enhance different elements in the metadata. And then this metadata get republished so that you can create different types of user interfaces over it, and we have developed a few. The key thing in the pipeline is, so these are the steps in the pipeline, from harvesting to staging to validation, developing a plan of what we shall do with the data based on what is missing, and then automated enhancing and presenting these to curators and users for verifying whether the automated enhancement worked correctly. The key thing is content enhancement, because when you look at metadata records, in many cases there will be, let's say, spatial extent missing, or keywords would be too domain specific or not provided. Such things as which instruments have been used, or what platforms have been used, what domain this data set belongs to, maybe not there. Organization may be presented as some kind of abbreviation that would be difficult to match the actual organization. People, typically when you have, well, I shouldn't say typically, but often when you have contact information, it will read please call rather than name of a person and the phone number. We developed several enhancers that would correct these things. In particular, correct spatial extent and assign keywords based on the information that we find in the metadata record or around it. All of the changes that are done to metadata document are saved in Neo4j database, and you can see that when we republish the data, there is an additional link to provenance, where you can see what happened with the record from the moment of when it was harvested to when it was validated, spatial extent has been enhanced, keywords added, and so on. The key thing is certainly keyword enhancer, because that would allow us to do faceted search over multiple records, and that is based on a collection of vocabularies and ontologies that we organized into an overall CINERGI ontology that incorporates things like CHEBI for chemical parameters, geographic names, GCMD keywords, and a few other things. SciGraph I will talk about a little bit later, and provenance components deal with recording everything that has been done within the pipeline and making it available for query and for search. And validation is done using OGC validation service, where we have a bunch of schematron rules that can be applied to a record to see, first of all, if it's syntactically correct, and second, if the content of certain elements is compliant with, complies with our expectations. SciGraph that I mentioned is a set of REST services that will help with annotation and semantic processing. So, for example, one of the services is annotation services I mentioned. You can submit a corpus of text to it, and it will extract terms in this text that are found in any of the registered ontologies, or in any, belongs to any of the nodes in the CINERGI ontology, and return you an annotated text where each found term will be referenced to the thesaurus where it came from. This is the location of the document. It's all publicly available. You can do, let's say, annotation search, plug in content, and then fairly quickly get results that will show you that will have all found terms annotated with their location in ontology. Okay. Yeah, so essentially what we have now, you can think of metadata before and metadata after, and contrary to common pictures of before and after, we start with a fairly slim metadata and end up with a very fat metadata document that has a bunch of keywords, multiple spatial locations perhaps, and there are two interfaces where you can compare the results. Before is, well, there are actually about 120,000 now, but that requires some additional step of solar indexing, so it shows only 15. And we kind of harvested this 50,000 and then decided to stop because it was messy enough. You can see that if you click Discover here, you can get data sets from multiple sources, which include Critical Zone Observatory and Chesapeake Bay Program and data.gov, EPA and CDC and ODC, and a bunch of other things, open topography. Some of them have cryptic names like Raquel files, because Raquel is one of the students who has worked on high-level inventory. But that is sort of not what we intend to expose. What we intend to expose is metadata after. It doesn't have that many records yet because we're still enhancing the procedure, and it takes about 1 hour to process 1,000 records on one machine. We're looking at how to scale it because now we have about 300,000 records that we need to process before the all hands, not before the technical meeting. So what you get here is when you do the search, you will see that each link has, each record has provenance information. I must say that it's currently down, so I'm not showing it. And then there would be categories that would be automatically generated. And at this point, they are generated with a separate script, which I guess has not been run on the latest pipeline run. But eventually, what you would have here is categories organized by instruments, domains, science keywords, and a few others. So what I'm showing is very much a work in progress, but we see the lights at the end of this tunnel. Steve is smiling. Okay, how we work with the communities. C4P is one of the groups that we started with, and there was a very extensive effort within this group to develop a list of resources. What we provide is a user interface where you can explore these resources. Let me actually show you how it works. I think I have it. Out here. Right, so this is the C4P collection. You can try to organize it by domains or by types of resource. Let's say we are looking at software and databases and repositories. Does the screen refresh okay on your side? Okay. Yeah, so you can zoom into these resources and see what they actually have. And for each of the resources, there will be some additional information plus a URL that you can navigate to. It's interesting to look at these distributions because, let's say, if you are limiting it to paleoclimatology. Paleoclimatology people mostly talk in terms of software. So there are lots of software and models here, not as many databases and repositories identified within that field. If you're looking at climatology, it's the same. Paleo environment, yeah. Stratigraphy, quite a different picture. We have databases and repositories, not that much software. Sedimentology certainly is different. If we look at it by domains, yeah, climatology we kind of looked at. Paleobiology, as you can imagine, these are mostly databases. You can see which databases we have. And another thing you can do is you can quite easily edit these resources. So you would say edit item. It will pop up a window where you can do the edits. Right, so you see that this form opens up and you can do edits right here, and the view will be immediately updated. In the same fashion, you can add a new resource. What am I doing here? I think I have, my screen is too small for this. Tiny screen. Yeah, so in the same way, you can click on add a new resource, and you can define, let's say you found another database or software that you want to add to the inventory. Just select what is the type of the resource, what is the domain, and it will be immediately added to that list. So this is sort of all-in-one. We hope user-friendly application that you can use within your community to organize the resources that you use. What I showed was a Silverlight version. We have spent a lot of effort on making HTML5 version more robust and usable. And I think that effort was quite successful. There are two implementations of HTML5 pivot software, so-called LobsterPod and OpenLink. And I should say that what we have now is more robust than any of them. You can try it by yourself. It works very fast. and it can do all the same type of analysis that we can do in Silverlight, maybe even faster. The only issue is that we don't have a change in level of detail on zoom. You remember when we zoomed in the Silverlight version, we could see some additional metadata about that source. Here we cannot, simply because HTML5 does not support this. All right. As I said, we have been having a CINERGI user meeting, because the issue is that kind of a simple data discovery we can do, and we have a mechanism of how we can add more sources, how we can harvest sources, pass them through the pipeline, enhance them, and so on. But what researchers are expecting is something more complex. Get the stable isotopic measurements from carbonates in North America of Silurian age, integrate them with all known fossil occurrences and geochronological estimates, and rotate all of the data back to their proper paleo coordinates. That is not something that we can answer now, but we can try to decompose such a query and see how we can enhance CINERGI to be able to answer at least decomposed query, and eventually when we add text parsing interface to it, then we should be able to do it automatically. But for now, we can say that we need, for example, in this case, to have a vocabulary of stable isotopes. We need to have a geologic time ontology so that we can understand what Silurian age is. Then we need to have registered terms that deal with fossils and some data sets that deal with fossils. And finally, software that would allow us coordinate conversion. Some parts of this query can be answered in CINERGI. Others, but altogether, it's not yet something we can do. Another query: look at all global climate models that have at least a 10-degree resolution, contain a coupled sea surface model, are written in Fortran, Unix compatible, and were created at NCAR. That would imply that we have a collection of models that are described using these characteristics: resolution, the language they're written in, organization that supported them. We actually have a collection of models. Let me switch to the browser again, and eventually we will make these models part of CINERGI. So let's do that. Yes. This is one of the. This is one of such collections where you have about 400 different models coming mostly from environmental sciences, and you can see how they are distributed by, let's say, the type of platform they run on, domains from which they get data, and you can do, let's say, if you're looking for, I don't have Fortran here, I'm afraid, but at least I can have Unix as part of the query that I mentioned before. So it's all an issue of compiling correct metadata to characterize models or other information objects so that your queries can be answered. Within the pipeline, as I said, we have an open API for enhancers, and you can imagine writing an enhancer that would try to reconstruct these fields from information available in model description or in some papers related to that model. So things like whether it's written in Fortran and resolution can be extracted from there once we have the correct enhancement. Yeah, so that's what we've been doing at this workshop, trying to walk through a bunch of use cases from different domains, identify some common patterns in them, and define a mechanism of how we extend the current version of CINERGI so that we can answer these queries by registering additional data resources, registering ontologies, and specifying relationships between terms. This is a list of URLs that I showed. More information is, of course, on the project website. That's a new link, a link to a new location. And finally, just a brief summary that deficiencies in documentation and content of metadata is one of the central obstacles for efficient resource discovery. When we are trying to compile high quality inventory of metadata resources, we have to enhance metadata, and for some types of metadata we can do this enhancement fairly efficiently. I believe we're ready for being tested in different settings, and in particular metadata curators from NOAA, NASA, Geosciences Australia have been quite interested in passing their metadata documents through our pipeline and checking the provenance to see if we can approach what they have been doing manually. Because there's a lot of effort within agencies, federal agencies, to curate metadata. Most of the work is done manually. We offer an automated way followed by manual curation, where you can see, you can essentially see what the machine has done and approve it or edit it. Unresolved issues are related to complex use cases, handling search to domain systems, because, for example, we can find data sets that contain observations that are of interest, but we can also find that AIDA would provide a more precise response to the query, especially about samples, or quasi-HIS would provide a more precise response to the query when it's about time series. And curation is a very big issue. This is the final slide, I think. And these are the propositions that we can make to the community. If your data facility spends a lot of effort doing manual curation, you may want to work with us so that we pass your data through the pipeline and see if we can enhance, if we can save you time on manual curation. As part of this enhancing, we also train our keyword assignment using some very standard machine learning algorithm. Essentially, we have about 1,000 metadata documents that a student goes through and checks whether the assignment has been done correctly, and then it's being fed back to the system so that the keyword enhancer knows how to assign correct keywords for that specific source. If you organize a domain community, we can set up a CINERGI community resource viewer. In fact, there is also a sandbox version. If you go to connection.earthcube.org, you will see an empty canvas that you can start populating with resources from your group. We would very much welcome contributions to curating existing inventories, especially high-level resources, and we are also starting a collection, a registry of functional components of geoscience cyber infrastructure that can be used to compose different architectures. And if you have interesting use cases, please send us, because this is the best way for us to figure out how to enhance the system. think that's it. Yeah, thank you very much.
Ilya, thank you very much for your presentation. So if you have any questions out there, please send them through the chat. You can either send them to Research Coordination Network or to everyone. Okay, so we have a question here. Will metadata enhancements made through the CINERGI pipeline be pushed back to the original resource providers?
Oh, good question. So far, no, but the provenance track of what we have done with metadata is available. And if you are interested in grabbing the new enhanced XML documents, you can do it via CSW or web accessible folder interfaces that we will support. So all of that will be available to the main repositories. If you want some direct, kind of more direct way or automated way of pushing the enhanced XML documents into your system, we can do that as well. But so far, the default way is that it's all available. You just go to the interface and select your source, and then see what enhancements have been done and grab them into it.
Okay, we have two questions sort of dealing with samples. So have you considered integrating IGSN, International Geosample Number metadata, to make samples discoverable? And then another one, just do you envision having sample level metadata in the inventory?
Yeah, we considered that about an hour ago, and before, of course. The issue is that so far we've been focusing mostly on data set discovery. If we want, we can certainly treat samples as data sets, and we can, given the pipeline, we can assign ISO 19115 metadata to samples quite easily and treat them in the same way as we treat any other object in CINERGI. So that would be one way to do that, but it's not a very semantically clean route. So we need, I think we need to talk through a bunch of use cases of when when the query is about observations or about samples that would be IGSN marked, how we can first perhaps discover data sets, and then if the query is about samples, hand it over to AIDA or to another system that deals with geosample numbers and with samples. Currently, we don't do that. At this level in CINERGI, we just discover data sets that may contain samples or time series, and then hope that, and also point to where this data set came from, so that people can go to AIDA or Quasi or other and do sample level or time series level or any feature of interest level query. So, not sure if it's well, I'm not happy with this answer, but that's the best I can.
We'll talk about it more during this user meeting.
Yeah.
Okay, so one question is, I think I heard there will be some assessment about the quality of the record. So who will do that and what does that entail?
The current plan is that once metadata pass through the pipeline, it will also be available through manual curation interface, which is essentially a forms interface where you can see how the machine filled out metadata information for, for that data set. And that piece is in the works. Because we figured that machine can do all sorts of weird things that you don't really want to show people. Huh? Yeah, Steve just, if you want to come closer. Yeah, so So this is one part, manual curation. Another part is that we do validation as part of a pipeline. So at several critical junctions in the pipeline, we see if the metadata is correct enough and complete enough. That is being done using schematron rules. Did I answer all of it?
I think so. Don't worry, there's a list. There's more if you're ready.
Sure.
Okay, here's a comment on the resource viewers. So the resource viewer could be very useful if an output list could be selected, like checked off, and then exported to a spreadsheet or an email, sort of like how some reference searches work. Is that something that might be a possibility?
It might be a possibility. No, I mean, I can show you some good thing where that we have done. I think if I just give me 1 second. So that's in this interface, you can add different databases or different resources to a cart, right? Like a shopping cart. And this is done for validation of how compatible these resources are, but they could also be exported into a list or into any document. Is this something that you have in mind, or yeah, but at least this is one mechanism to do selection of resources into some kind of a bag, shopping cart, list, and then export this into usable form. All information in these viewers is accessible via OData interface, which is essentially a table interface. So you can extract, you can get a table from these resources by supplying some selection criteria via OData request.
Okay, so far we have one more question. So this question is, if a data set has a DOI and an official citation, how will this DOI and citation be incorporated into the enhanced metadata?
Yeah, in metadata, in ISO 19115, of course, there is citation. As to DOI, kind of the simplest default way for us to do that is to throw it into a keyword, but it's not the perfect way. There should be some additional, yeah, MDID, right. That would be on the citation part, right? Yeah, so again, I'm referring to Steve, who is near and he knows more about the structure of ISO 19115. So citation and MD identifier would be potential fields within ISO 19115, 19139 to hold this info.
Okay, I don't see any other questions at this point. And Ilya, thank you very much. It's great to be able to be in the same room to give this webinar. So thank you again for giving the presentation today. This webinar will be available later, both at the EarthCube website and the C4P YouTube channel. And for future webinars, please check the C4P webinar schedule at the earthcube.org site. So thanks for attending, and see you next time.
Thank you.